Hello, everyone. Welcome back. Let's see. So, as we all know, we're in the second half of the semester, right? And we're focusing on implementing the back end, right? The server side of a client-server application. In the last couple of lectures, we discussed how to implement an HTTP server using Node.js and the Express library. Right? We created several routes, right, that allowed the user interface, the React.js user interface, to be able to integrate with the server, right, using HTTP requests. We moved the data that we had called a database, right? Not really a database, right? It's just a collection of objects and arrays, right, that we collected into a single data structure that used to live in the user interface. We've moved it over to the server side, right? And then the server, to give access to the user interface, right? We created several routes that allowed the user interface to integrate with the server, right? So that all the operations of accessing data, updating data, retrieving, deleting, right, all the CRUD operations now live on the server. And we did this to escape some of the limitations that we had encountered, just using a plain old React.js application, right? Certainly we can render all sorts of things in the user interface. We can, modify data structures, right? We can create content, delete content, right? And interact with the user, right, as they click and drag the application. Right? But none of those changes were permanent, right? That's and because we don't have access to the file system, we have limited access to the network, right? No database, so we moved that, all those operations over to the server, where we do have access to the file system, database, network, right? But we had to integrate these two sides of the application using an AJAX HTTP requests, right, between the client and the server, right? And so we made a lot of progress, right? We moved all that data over to the server, and yes, right, we were able to create some permanency, right, on the changes. We saw that now we can, ask the server to create content for us, and now the client React.js application can, survive a refresh, right? It can go back to the server to reestablish the state of the application, go get, data sources from the server, and any changes that we make are persisted in the server, but only temporarily, right, up until the server is still running, right? So to make it truly permanent, right, we need to add a database, right? And that's where we're going to start discussing today, right, in our next lecture as well. So today we're going to introduce assignment 6, right, where we are going to discuss how to create a server, a MongoDB server, that is going to allow us to implement a permanent storage solution, right? We're going to replace the JSON data structures that we migrated from the client to the server. We're going to replace that with an actual database, right? A MongoDB database. And so all these operations that all these CRUD operations that were manipulating a data structure, now they're going to be manipulating tables or collections, right? Inserting, updating, and deleting records, right, into a permanent storage solution. Okay, so that's the plan, right, for the next couple of lectures. This will be the final major topic of our course, right? This will be the final layer, right, in this multi-layered application, right? We had multiple tiers. We've first discussed the user interface tier or layer, right? Then we added the server as the middle tier, and the middle sitting in between two things, right? And where the last tier being the database. Okay, so that's going to be our final major topic. We do have a couple more topics that we will be discussing, right, in a couple of weeks, right? But it's not a major main topic. Although, right, we'd definitely like to be able to discuss, for instance, integrating with outside resources, right? Other third-party APIs that might make their data sources publicly available to the rest of us, right? We'd like to explore how to integrate with that. Also, we'll explore integrating, for instance, with AI tools such as ChatGPT, right? How we could add some of those features into our application. One cool thing would be that all the Canvas application that we've been working on, right? That we could use ChatGPT to generate some of that content, right? That I'll give you the title of a course, right? And you give me suggestions of what the modules might be, right? And for each module, right, give me 10 lessons within that module, right? And give me help me create quizzes, right? Questions, answers, and whatnot, right? So anyway, so that's coming up a little later. So this next couple lectures are going to discuss how to integrate a non-relational database of MongoDB. Okay. So today is the formal release of assignment 6. Right, you're welcome to get started anytime. Also, there's a couple of quizzes. They're still outstanding. If you haven't worked on that, please work on that. And then next week is next week is already Thanksgiving. Wow. When we come back from there, we'll continue discussing integrating with third-party APIs, integrating with ChatGPT, right? And I'm sure you're all feverishly working towards the project, right? I hope you have already started. Right? You have plenty of skills to get going, right? To create prototypes for the user interface, right? Creating a server, styling it, creating all the navigation part, right? Creating endpoints to you can create some fake data, right? That you can access through some RESTful APIs. You can build all that already. So you should, I'd suggest you get going on that. The project is due I guess the beginning of the second week in December, December 8th, and so I will be the TAs are going to be sharing a spreadsheet with you so that the teams can register for a demo. Right, so you'll register for a demo where that should take you no more than an hour, maybe less, where you're going to demo your project as a team, right? You're all going to agree to time slot. Right? You'll get to choose your TA and the time slot that you want to demo. And that demo week is going to be the last week of the semester, and I'm going to share with you a checklist, right? So that the TAs and yourself can go through that checklist, right, to confirm that you've implemented all the different requirements, right, for whatever project you might have chosen. It's basically the requirements that I already shared with you, but in a checklist format, right? It's going to ask you, right, can you log in? Can you register? Can you go into your profile and edit some information in your profile? Can you create a relationship between you and another user, or a relationship between you and some object, right? Implement one-to-many, many-to-many relationships, right? So all that I'll be sharing with you soon, right? There's 2 different checklists depending on whether you chose the quizzes project or whether you chose the more generic project. So there'll be 2 different set of checklists, because they are 2 different sets of requirements, right? So you'll fill out the one that you chose for yourself, for your team. Okay. Anyway, so that's all coming up. The exam will be that the week of the 8th, right? So right where the project is due. So that week the exam will be available. Second exam. Never mind this date. Right? It's around the date of between that Monday, right, of December 9th, I guess. Right, all that week the exam will be available, right, and so you could take the exam anytime that week. Okay, and I do need to have grades all done by the 16th, and so that's so that week is going to be very, very busy, that last week. Right? So if you need help, you need support from the TAs and myself, please reach out to us as soon as possible. Right? Because that week we're not going to be very available. Right? We're going to be running around trying to wrap up the semester, right? And making sure that all the assignments are done, or all the grading is done. So please reach out to us earlier. Okay. All right. Let's talk about databases. Yeah, so we're going to be adding a database to our application. Right. Up to this point, we've been implementing a user interface. Right, that was the first half of the semester, right, where we introduced HTML, CSS, JavaScript, React.js, right, and then discussed about navigation. We discussed about maintaining state, right, in the user interface, and then we reached a limitations of what you can actually do just with those technologies. So we introduced implementing a server, right, using Node.js, right? And with Node.js, where we discussed, we moved all the data from the client, we moved it over to the server, right? And then we exposed that data to the client, right, through a interface, right, a web interface, a RESTful web API that allowed the React.js to request the server to do some work on its behalf, right, of creating content, deleting content, updating content, and then these routes, right, implemented paths or URLs, right, that the user interface can integrate with, right, to send these requests, and then these routes implemented those actions, through a data access object. Data access object is a very popular design pattern, right, that groups together various operations on a particular data source, right? So we had a DAO that can manipulate users, right? It could create, read, update, and delete users. We had DAOs for courses, create, read, update, and delete courses. There's a question here: are we supposed to be led down installing middleware for our backend? There are partial implementations here where you configure sign in, sign up, but we can't check if sign up is working because create. Okay, so that's a very specific question. So let's save that for the office hours at the end of the lecture. Okay, so we could take a look at that together. So what we're going to do in this assignment is that the current DAO implementation, right, manipulates a data structure, right, that is read from a file system, right, and then all the updates are done in the memory of the server. The server makes a copy of this data structure in the memory space of the server, right, and all changes, all updates or deletes, all operations are done on these data structures in the memory of the server. So if the server reboots, right, all those changes are lost, right? To make it permanent, right, the server would need to save those changes, right, to the file system, either to a JSON file, right, that could be reread, or better yet, right, what we're going to do is that we're going to introduce a MongoDB, right? There's going to be a separate server that is running, listening at a particular port, right? It's going to have its own data files, right, that it's going to read and write to the file system, and we're going to use a library called Mongoose, right, that is going to allow us to integrate, right, with this database. Now we're going to be using a MongoDB, which is a non-relational database, right? Although we could have chosen a relational database, we could have chosen SQL Server, MySQL, Oracle, right? All these provide relational database implementations, right? And we could have done that, right? And then we would have used a different library, right, to integrate with those databases. Right? But I'm sure you've done database courses, right, in prior semesters, or maybe you're doing that right now, right? And so you have plenty of experience or chances to play around with relational databases, right? Maybe not so much non-relational databases, and that's where this one is a little more interesting, perhaps. Hopefully, you'll find this a little more interesting. This is a non-relational database, and one peculiar aspect is that it does not define schemas, right? It does, usually with a relational database, the first thing that you do is that you declare a table. Do you declare the structure of the data? You say that this is the name of the table, this is the fields of the tables, and the various primary and the primary key and the various properties and data types, right, of those fields. That's what you first declare, and then you go into insert, update, delete, right, records into a table, right, in the relational database. Not here, right? In a non-relational database, there's no need for declaring a schema, right, or a structure for the data. Typically, you just collect. You're free to collect and mix, different records of different types and whatnot. Not that we would do that. Not that that's a good practice at all. But the role or the responsibility of validating or checking to see if the fields are the correct data type, that role, that responsibility does not fall on the database. Instead, in a non-relational base, typically that role is taken over by the application. The application, right, our Node.js server, will take the role and the responsibility to validate all the data before it gets inserted into the database, right? So the schema, instead of being declared at the database level, it's declared at the application level, right? So Mongoose, the library that we're going to be using, right, is going to allow us to declare these schemas, right? We're going to declare schemas for users, for courses, modules, assignments, quizzes, right? And you're going to declare the fields, the various fields that you need to store. Right? So for a user, you might have username, password, first name, last name, so on and so forth. And so that's what we're going to be declaring these schemas, right? And their role, right, is the role you would expect, right? They're used for validating, making sure that what you're going to be storing, right, it'll enforce certain restrictions, right? That certain things are unique, certain things are required, right? Some that they have to be strings or dates, right? Or numbers or booleans or whatever, right? So that's the responsibility of the schema, and we will define them using the Mongoose library. Then also in Mongoose, we will declare what are called models, right? Mongoose models. And what they do is they allow you to interact with the database, right? It allows you to create a connection with a particular collection in the database. Right? Collections are the equivalents of tables, right? It's a collection of records. Although in non-relational database, we don't say records, we say objects, documents, right? We store a collection of documents as opposed to as a table of rows, right? So models are going to allow us to create, read, update. It provides the CRUD operations to insert, update, delete data into the database. Right? And what we're going to do is that we're going to rewrite our DAOs, our current implementations of DAOs are working with a data structure, right? It's just a big object with a whole bunch of arrays, arrays for courses, arrays for users, arrays for assignments. Right? So we're going to replace all that, and the DAO instead is going to use the model to be able to do all these CRUD operations, but on the database. Okay. Now, some of the same challenges that we faced when we were integrating our React application with our server, we're going to find some of those same challenges to integrate our Node.js server, to integrate it with the Mongo database, right? If you remember, the React application, also had its data structure in the user interface here, right? And we moved it over. When we moved it over, right, the operations became asynchronous, right? This communication between the React web app and Node.js is asynchronous. So a lot of the functions that implemented the CRUD operations, we needed to rewrite them so that they were asynchronous. So we introduced the syntax of async await, right? That allows us to integrate these two layers, right? Well, same thing is going to happen now, right? That we're going to move the data away from the server. We're going to move it over to the database. Now the communication is also going to be asynchronous. So we're going to have to rewrite some of this implementation, right? To, and have to introduce again, right, the async await syntax, right? Because the communication between these two layers is going to be asynchronous, right? So this application is going to be, in the true sense of the term, it's going to be a distributed application, right? That could be distributed all over the world. You could have the React web app, running on a browser. The browser can sit here on the East Coast. Our server can be running, halfway across the world, maybe somewhere in Eastern Europe, right? Connecting to a database that is running maybe somewhere in Asia, right? So these are three processes, right, that are spread out all over the world, right, and talking to one another through either HTTP, right, the client with the server, and using the Mongo protocol, right, to integrate these two layers, right? Obviously, when we implement this locally on our machine, all of these processes are running on our laptop, right, on our computer, right? So they're all running on the same IP address, right? But when this gets deployed remotely, where this will be running on Netlify, this is going to be running on Heroku or render.com, the database as well, right, is for development purposes, it is going to be running locally on our machine. But when it gets deployed, right, remotely, it's going to be running somewhere in Mongo Atlas, right, in a service that Mongo as a company, right, provides as a service. Okay. All right, so let's get started. All right, so the first couple of sections, right, are going to walk you through installing, right, and configuring your database. Right? So please go through this, right? It kind of handholds you how to do it for both for Windows and for Mac, right? For Mac is fairly simple. You can use Brew to install MongoDB Atlas, right? So this will download and install, locally on your machine, right? You'll install it as a service, meaning that when you boot up your machine, the database is going to start automatically, right? And automatically be listening at a particular port, okay? And this is great, right? So very convenient. The database is always running, and you should, your laptop or your machine should be powerful enough to have this service running in the background. You're welcome to stop and uninstall the service at the end of the course, right? But I think this is the easiest way that you can install and have it running always in the background. For Windows, also for Mac, right? You can download the community edition, the MongoDB community edition, right, and install it locally on your machine. Also, you'll have the chance to choose whether you want to install it as a service, right, meaning running in the background for both Mac and PC. And PC. And I strongly suggest that you do install it as a service, but you can also allow you to install it as a standalone application that you can run from the console. That's what I'm going to do, right? I don't have it running as a service, right? And you can run it also from the console. So that's what I'm going to demonstrate, right? So if you do run it from the console, you install it not as a service, right? Typically, it'll install on a Mac. Typically, it'll install under user local, right? And it'll create a folder, MongoDB, Mac OS, something, right? And there'll be a bin file folder, right, with executables. On Windows, typically it'll install somewhere under program files, right? Mongo, in the application, right? The folder where it gets installed, and there'll be a bin directory there as well, right? So to get started to run the server from the command line, right? You need to execute the MongoDB executable that is under the bin directory, right? So for Mac, right, it'll be user local, right? The folder bin MongoD. And for Windows, the same thing, right? Now, if you run it locally from the command line, you'll need to provide a folder, right, where the server stores all its data files, right? And you provide that as an argument, right, as a parameter, telling it, when you run it, you tell it where is this folder located, right? So I put the folder in my local home directory. That's where I put my data file. So that's how I run it, right? I run it from my home directory. I use the folder, right? I tell the path where the MongoD instance is. I run it. I give it the location of my data from my home screen, my home folder, right? And then it starts up. Right? So I'm going to demonstrate that. So here I am in my home directory, right? And my executable is in MongoD. I don't know if you can see that. Is in MongoD under the user local MongoDB something/bin. And I have a local folder called data, and so I provide the location of that. So I run that. The server is going to boot up, right? It's going to be a standalone application that's running, right, and listening for incoming requests, right, at a particular port, right? The port, I believe, is 27,017. Somewhere in here, can't find it. Somewhere you can see the port number. Anyway, And so we can connect to the database, right, through that port. Now we can connect to it in a couple of ways. One of them is using a UI tool, right? Some that we're going to be using in a minute. And the other way you can connect to it is through some library, right? That we're going to do programmatically, right? We're going to be able to connect, log in to the database, and then use the API for the library, right, to be able to insert, update, and delete data from the database, right? First, let's demonstrate using the user interface tool. The user interface tool is called MongoDB Compass, right? That you can download and install, right, following the directions in the assignment, right? So, for instance, you can go here to a folder and download the MongoDB Compass. You can download it, you install it, right? And this is the tool. This is the tool. So in the tool, you can create. It asks you to connect. You click on the connect. It connects to the server. Once it's running, you first have to run the server, then you run this tool, and then from here you can create any number of databases, right? So let's connect. Here we go. So this is it's already connected to the server, and I can make it bigger, and you can create new databases. So I'm going to create a new database for this section, right? So this will be Canvas. No, not new connection, new database. Sorry, here. The database will be, Canvas. So this is CS 5610, right? And this is fall 24. Okay. And so yeah, so that's the name of the database. Now in the assignment, I use the name of the database as just plain old Canvas. But since we have different sections, right, I'm creating a different database for different sections, right? So I can teach the sections independently. Then you have to provide a default name for a collection. Again, a collection is the equivalent of a table in a relational database, right? And we're going to have several collections. One we're going to use for storing user data, right? Another one for courses, modules, assignments, quizzes. Okay. So let's create a collection for users. So users, create a database, and there it is. We have the users collection, which is currently empty. Right now, you can either add new documents, right, new records into the database manually. Right here, you have two ways. One is you can insert individual documents one at a time, or you can load JSON files that already have data. Right? So I'm going to insert a single document, representing a particular user, right? So let's so notice that the data that gets inserted into these documents is formatted as JSON, right? It does create a default field called _ID. So this is a primary key that uniquely identifies this document, right? Notice that this is the name of the field that we've been using, for several weeks. Okay, that uniquely identifies courses, users, modules, and the reason I chose the name of that field _ID is because I was looking forward, right, that at some point we were going to be using a database whose primary key is called _ID. I was future proofing, right, all our assignments that we worked on, A2, A3, A4, and so on. So anyway, so let's create a user. If I remember, users have several fields in there. You have username, password, first name, last name, role, and so on. Right. So let's create a username field, and the value I'll call it Bob, and then the password I'll just go with 1, 2, 3. Right, and then let's create the first name. This is Bob, and then last name we'll go Marley. Okay. And I'll give Bob a role of admin. Let's say insert, and there it is. So it creates a a single record in the database, right? And then you can edit the fields, you can add more fields, and so on, right? Or you can delete it, okay? You can copy it, duplicate it. You can also add several documents all at once, right? By importing a JSON file. So I already downloaded a JSON file that I am providing, in the assignment. In the assignment, we do give you links to courses and users and assignments and modules. So insert them all, into the respective collections. So create a collection for each one. Create a courses collection, a modules collection, assignments collection. Users we just did, right? Create that and then insert these JSON files that I am providing. Okay. So I'm going to do that. Here's the users. Now notice that this user, I'm going to make it a little bigger here. Notice that the data in here, right? Oops. The data, right, contains just fields, right? And notice that one thing that it does not contain is the primary keys, _ IDs, all right? So make sure that any data that you insert into a database like this using this, uploading the JSON file does not include the primary keys _ ID, right? Because what we want to do is that we want to let the database figure out the values of the primary key for us, right? As opposed to us providing those values, okay? So make sure that it's not there, right? We're going to select that. We'll say select, and it says import, and there it is. So we have now, Iron Man, Dark Knight, right? Captain America, right? We've inserted 9 records in here, right? So basically, this is going to take the role of the JSON files, right, and the JavaScript files that we've been using so far, right? We're going to replace that, so that the data actually only lives in the database, right? No files. Everybody good? All right. All right. So we imported that. The first section here walks you through, how to use the database from the command line. You can also interact with it from the command line. The tool gives you access to the command line. Where is the command line? Where to go? Usually it's down here. There's a bash link. Oh, there it is. MongoDB shell. See that? So this opens up a shell where you can interact with the database manually, right? You can do things such as show the databases. Right? So all these databases are listed here. So this is the user interface, graphical user interface, or you can do the operations manually, right? And so you can also you choose a particular database. So maybe this one, the one that we just created. You can say use that database. Once you've gone into the database, you can show the collections. Right now, you only have the users collections, right? You can interact with that collection. You can say, users dot, db dot users dot find, right, and retrieve, right, all the records. Right? You can also update, insert, delete, right, using the command line. Not that you're going to need to, right, but it's useful, right, to also be able to interact with it manually, right? So now we're not going to be using this manually. Instead, we're going to be using the graphical user interface, right, to interact with the database, right? But, right, please go through the section that walks you through, how to use it manually as well, right? It's a great skill set to have. All right, so we want to be able to interact with the database programmatically, right? For instance, we would love to be able to create programs such as this. This is a program, right, that connects to a database. It lists all the databases and allows us to do all sorts of CRUD operations, create, read, update, delete. If we would want to build something like this, how would we do it? Well, we're going to be using a library called Mongoose. right? So Mongoose is going to allow us to programmatically interact with the database, log into the database, go fetch data, update data, delete data, right? So let's, on the server side, right, we're going to stop the server for a second. We're going to install Mongoose. There it is. And we're going to restart the server. All right, so once we have Mongoose installed, right, we are going to try and connect to it. And the way we're going to do that is through the index, right? In the index, we're going to import Mongoose. So import Mongoose library, right? And then we're going to connect to it. And the way we're going to connect to it is we're going to create a string. This is a connection string, right, that we're going to use to establish a network communication with the server. Right? And the URL has the following structure, right? It has the protocol, right? It's not HTTP. It's the MongoDB protocol. Then the IP address of where the server, where the database server is running. In our case, the server is running our local IP address, right, in our local machine, right? So it's local to us. So it's 127.0.0.1. And we know that the database is listening at port 27,017, right? And then followed by /canvas. So canvas would be the name of the database that we want to connect to, right? And that's not the name of the database we're going to use, right? The database we're using is this one, Canvas CS5610 FA24. So Canvas, oops. So CS5610 FA24. Okay, now this is going to connect, right? Mongoose.connect establishes a network connection to the remote database, right? And now we're connected, right? Now we want to be able to configure this so that not only does it work locally, but it also works when we deploy it, right, on Heroku or render.com, right? So to do that, we're going to move this configuration here, this declaration of what URL to use. We're going to, instead of hard coding it in the, inside of the source code, right, we're going to move it to an environment variable, right? So we're going to create an environment variable, which we do already have, right? And in here, right, we're going to create a Mongo connection string, right, that connects to MongoDB, 127. So this value right here. I'm going to grab that and right there. Save that. Perfect. Okay. And so now what we're going to do is that instead of hard coding this content here, we're going to use the environment variable, right? So let's do that. We're going to load.env config, which we already have that. And so our connection string now is going to load that information from the connection string as opposed to hard coding it. Now, if this is not defined, right, because we're running this locally, right, in our local machine, well, we do have it declared. There it is, right? So it's using that. But as a precaution, right, if it's not defined, we're going to default it to our local database, okay? And then we connect to the local database over here, okay? All right. All right, so let's start communicating with the server. We're going to start fetching information. Right now, the only information in the database is this users, right? These users, and we like to be able to retrieve them, right, and make them available, right, so that from the server, from the DAO, I like to be able to find users by username, by credentials, and I like to be logged in, right? I like to be able to sign up, so I need to create a new user, right? So the way we're going to do that is that first we're going to create a schema. Right? So again, the schema, a schema for in the context of databases is the configuration, right, of the structure, the declaration of the structure of the data source, right, that we're interacting with, right, and is used mostly for validation purposes to make sure that when we insert or when we update records or documents, right, in a collection, right, that it follows certain constraints, right? In particular, right, that it should use only these fields, right? So username, password, first name, last name, and so on and so forth, right? And those fields need to adhere to certain constraints, like for instance, the username and password. So all these 5 fields, they're all strings. You know, we can, and also usernames has additional constraints saying that it's required, meaning if you try to insert a document without a username, the insert will fail. Also, another constraint is that it is unique, meaning that if you try to insert two records with the same username, it will fail the insert. Okay. Here's another one. Password is also a string, right? And it's also required. So you need to, when you insert a new user, it needs to at least have the username and password, right? It's okay if it doesn't have first name, last name, email, right? It's okay. It's not required, but definitely has to have at least a username and password, right? So both username and password are required, but notice the password is not unique, right? It's okay for two different users to have the same password, right? They wouldn't know, okay? So now if you don't have any other constraints, right, you can declare just the primitive data type, right, of that field, right, which is, you can either declare it like that, just by the primitive, by the type, or right, you can provide it using an object, configuration object like that. So if you have several constraints like required and unique, then you need to use the syntax, right? The object that configures it. If you don't have any other fields, then you can just be more compact, right? And just provide the data type like this, string, right? All major primitive data types are supported: strings, dates, Boolean, right? Number and whatnot, right? And so here, date of birth is date. So we introduce several constraints: required, unique. Several other constraints are enum and default, right? Default, as you would expect, right, provides a default value for that field. So role, the default value for role is the string user, right? Enum allows you to create an enumerated data type saying that these are the only valid values for this field. So yes, it's a string, but it's not any string, right? Only the following strings are allowed. Your role can only be either a student, a faculty, an admin, or a user. And that's it, right? Everything is strings, dates, and strings. It also allows you to configure, right, the collection where this is going to be stored. Now, we already selected this name, right? We called it users. There it is. So the schema is going to be used to validate data interactions with this user's collection. Okay. All right, so we have the schema. We're exporting it here, and so next we have to create the model. So the Mongoose model is going to provide the API, right, to interact with our users. Right, so let's create the model. Again, this is all on the server, and so a model is fairly simple, right? It just it imports the schema, right? And then using the Mongoose library, it creates a new model, instantiates a model object, right? Based on the schema. Right? So what this will do is that it'll create a model that knows that it's going to talk to the user's collection, right? Because the schema declares where it's everything stored, right, in the user's collection, right? And then provide through the model, it'll provide primitive functions that will allow you to retrieve data, create data, update data, delete data, right? Another something very important thing that it does is that it gives a unique name, right, to your model. In our case, we're calling it user model. And unique meaning that as we create different models, right, one for course, one for assignments, one for modules, and so on and so forth, right? Each one name for the model needs to be unique, right? Like you can't have two models, right, that use the same name, right? That makes sense. Now, for now, this name is irrelevant to us, right? But eventually, a little later, when we get into creating relationships between collections, this name will be relevant, right? When we want to say that one course has many modules, there's a relationship between the documents in the courses collection, right, and the modules collection. There's some relationship, and to establish that relationship, that's where the names of the models comes in. Okay, so we'll see that a little later. All right, so we have the model, now, right, we are ready to start refactoring the DAOs, right, that we might have implemented in earlier assignments. Right, the current DAO implementation, at least for users, is using, right, the database object right here. See that? It's using this database that is basically a data structure that collects all these arrays, right, into one big object. So we're going to do away with that, right? We're no longer going to do that, right? And instead, right, we're going to comment that out. So no more are we using the database. So this might have crashed the server. Yeah, it crashed the server, right? And it's because right now, right, you have you're trying to grab users from the database, right, which is no longer there. Right, so we're not going to use that data structure anymore. Instead, we're going to recreate these to use the model that we just create, this model over here, right? So here we're going to import that new model. So import model from model.js, right? And so we're going to rewrite all these, right? So for instance, for create, right, instead of using the users in the database, right, we're going to say, return model.create. So create is going to insert this JSON object into the database. Now that user object that we're inserting better have, right, the schema, right? We're going to have the username and password, first name, last name, blah, 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 right? Based on that schema. It's going to be validated against that schema from where the model was created from, right? One thing that we might want to do before it gets inserted into a database, make sure that it doesn't have a primary key, right? Because we want the database to create the primary key when it gets inserted. We don't want to create the primary key, but throughout your assignments, maybe starting from assignment 3, right? We did create primary keys in a user interface, so that user interface primary key might make its way here in the DAO. So and that would screw up the insert. Right? So to make sure that primary key that we might have created in prior assignments, so it doesn't make it here, we can remove it. We can say delete from the user object. We can remove the primary key if we ever created it in upstream. Okay, because we want to make sure that the actual database is going to do the insert, right, and it's going to generate a primary key for us. Okay, find all models, right? We don't have users anymore, so what we're going to do is that we're going to use model.find. So model.find, find is the operation that retrieves all the documents from the database. This is the equivalent of select star, right, from users. So this is the equivalent of select star from users. That's the equivalent of doing that in a relational database. Then here we are this retrieves all the documents. This one retrieves a document, whose primary key is user ID. So to do this, we can use a model find by ID. So that's a function, right, in the model that allows you to filter, right, documents by its primary key, right? And so we're providing the primary key as a value. So find by ID automatically, filters by that primary key. Here, find by username, we want to filter, but not by a primary key. We want to filter by a username, which is also unique, right? But it's not the primary key, right? So instead of using find, the JavaScript find, we're going to use the model. We're going to do model.find. So find one, allows you to find a unique document, a single document, right? Following the predicate that we provide here, right? So a pattern match. We want to pattern match from all the documents in the database. We want to retrieve one whose primary key is, whose field matches, right, the object that we're going to hear. We're going to say that we want to filter. We want one document whose username matches the username argument that we're passing in here. So this is an object that is used to pattern match and filter the documents in the database by that field, by that value. Now, because here we're using the name of the property is the same name as the value, you might remember that in JavaScript you can you can abbreviate that as follows, right? You can say, model.find1, right, and one where username, like that, just that, right? You don't have to provide the value parameter, okay? But yeah, that's a JavaScript thing, not a Mongoose thing. How about filtering by credentials? Okay, so instead of using this array operations of finding things in the array, we're going to comment that out. We're going to use a similar model, right? So we're going to do model, again, find one, but we're filtering by not only our username, but we're filtering also by password. And again, because the property and the value have the same name, right? We can abbreviate that by just keeping the property like that. Okay. Okay. Right here. Okay. Then update. There's a couple of ways of doing update. So we're no longer going to manipulate the data structure array, right? Instead, we're going to do model dot. So there's two ways. One is find by ID and update, right? That works by providing the primary key to find the document. You provide a new version of that document that you want to update with. So these are all the update values. Maybe it's a new password, maybe it's a new email, a new phone number, whatever, right? And what's going to do, it's going to merge the old values with the new values, right? And that's going to be the updates in the database, right? Now, it's also smart enough to know that if that document doesn't exist, if the user ID, if there is no document that matches this primary key, what it'll do is that it'll insert this document into a database, right? So it's very convenient. So it works like an upsert, meaning if it finds an existing document for that primary key, it'll update it, right? It will make the changes. But if it doesn't find it, right, because that ID doesn't exist, then it will insert. So it's an upsert, right? So that's one way of doing it. The other syntax is that you can do model dot update one, right? So update one works slightly different. You provide a filter, right, to identify the document that you want to modify, right? So it has two arguments. The first argument is the filter. You say, so I want to find the document whose ID is user ID. This identifies the document that you want to update. And the second argument is how you want to update it. So here we're using a generic set, saying $set. What this does is that it also merges. It says, okay, well, you're going to provide here, right, in user, you're going to provide the field and the values, right, the field that you want to modify and the new values that you want to provide, right? So that's an object, right? So the field and the value, field value. So only the fields that are listed there, and if the value is different than the value you provide, then it'll update the field. Otherwise, it'll leave it alone, right? So that's one way. So we're going to use that. And finally, delete, right, the old implementations that you filter out, that particular item from the array. You would have an array, so we're going to do model delete one, right, and then you provide the ID that you want to delete, right? And this removes the record from the database. Okay, make sense? So yeah, so this is a re-implementation, refactoring of the DAO, so that instead of going out to the to the database files, right, it's going out to the real database, right? It's going out to the MongoDB database. All right. So now that we have the DAO, the current implementation of the routes, right, was expecting to use a DAO that was manipulating a local data structure, right? Made up of objects and arrays. So all these functions, right, are asynchronous, right? The original implementation, meaning they're not blocking. I'm sorry, they are blocking, right? So they stop, right? They wait until they're done doing the update in the local variables, right? And then they come back, and then you can continue. Now, because these DAO now are not manipulating local data structures, instead, what they're doing is that they're going out, right, to a server that were connected, right, that might be, running halfway across the world, Right now, these communication, right, between our Node.js server and our database, right, that communication is now asynchronous, right? So to do that, right, we have to basically do the same thing that we did, to integrate the React.js client with the server, right? We had to convert all these function calls into, asynchronous calls, right? Not synchronous calls, right? So to do that, right, we need to tag all our functions as asynchronous functions, right? So we need to say that these are all async. Right? So we need to do async to all our functions that are talking now to the DAO. Right? So all these are async, async, async. Right? Async. Anywhere where you're working with the DAO. Anywhere where you're working with the DAO. Okay, there we go. And now also the actual invocation of the DAO command, right? That is going to do the remote connection to the database. These are all need to be added with await. Right, so let's add await to all our DAO communication. Await. So these are all await. Here, wait. I think here we go. That one. Yeah. So the DAO is not yet using the connecting to a database, not yet, but it doesn't hurt. There we go. Okay. All right. Anyone else? Let's see. DAO. DAO. Await. Okay. All right. Okay. Yeah. So we tag them all using async await because we are connecting to a database now, right? Let's continue. All right. Yeah. So let's focus first on implementing some of the user-related functions, right? And for instance, being able to sign in and sign up, right? Profile and whatnot, right? Right now, a lot of that code is using routes that are implementing were implemented with the array in mind. Now, no longer, right? And so we need to refactor them. In particular, the sign up, the sign in, the profile, all those as asynchronous, which we did, I believe, right? Let's see if we got them all right. So let's see, sign in. Okay, so sign in. Sign in, username, current user, session, blah, 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 return. Current user, JSON, return. Okay, yeah, so we did implement it. Perfect. All right, how about sign out? Sign up. So sign up. Let's see, we have the find a user by username. If you find it, we send back an error, right? If not, then we create an insert to create user. We stored it in the session, and then perfect, excellent. Okay, so we should be able to get that going, right? Also, another thing that we can check real quick is find all users, right? So that should allow us to retrieve all users, right? So let's try it. And that's mapped to what? Just to try to see if the connection to a database works, right? So that's mapped to what? Get, there it is. So API users, right? So right now this is not even implemented. So let's implement it. So this is going to be async, right? And we're going to use the DAO. There we go. So it's a DAO find all users, which does a model find from the database. Perfect. Stores it locally within a await, and then we return users. So let's see if that works. Right. So let's go here and retrieve all the users. Right. So localhost API users, and there it is. So we have Bob that we did create, right, in the database, right, with the Bob Marley, right, all the users from the database. Perfect. Just to confirm that this is really connecting to a database. Now let's make a change in the database and confirm that we get the latest. So for instance, this one says Bob Marley. Let's go to the database and modify this document, right? So edit, and instead of Bob, we'll say Robert, right? And we'll do update, okay? Now if we go back, right, and refresh, we have Bob Marley, refresh. There it is, see, Robert Marley. So yeah, we indeed are connected to database. And the intent here is that the user interface no longer is going to use any data sources, in the user interface, and no longer is going to use data sources in the server. Instead, right, it's going to connect, integrate with these URLs programmatically. Is going to come and fetch the data that comes from the database. Okay, all right. All right, so we have retrieving all documents from Mongoose, which we did, model, and we have the find all. We just tested that, so that totally works. How about being able to retrieve all users from the server, from the client, from the React.js, right? Let's implement, for instance, if you log in as an administrator, like Robert Marley is an administrator, yeah, I should be able to manipulate all sorts of data, including existing users, right? I should be able to display all the users, right? Edit users, delete a user, right? Create a new user, right? As an admin, I have full control over all the data sources, okay? But only if I'm an admin. So let's do that. So here's a find all users. We already implemented on the server. We just tried it out. There it is. But let's try and access that from the client, right? So we'll create in the account client, right, that we have somewhere here, Canvas client. Let's implement find all users. Do we have that? We don't have it, right? Find my courses. Okay, so let's do that. Let's in the client, let's implement find all clients. Let's paste that in there. Perfect. Right, and then what we're going to do is that we want to display that. We're going to display that using the a table that we created in a prior assignment, right? That was used to display the users in a particular course, right? So let's tweak that a little bit and make it a little more generic, right? So that instead of only being used for displaying users in a particular course, right, we can use that same table, right, to display all the users, right? So what we do is that the initial implementation was to, have this component go fetch the users, right, from the database and whatnot, right, and then filter the users from the based on the enrollments. So what we're going to do is that we're going to make that more generic, right? We're going to say you're not going to be responsible for fetching anything. Someone else is going to fetch the users and it's going to send you, just the array of the users. You're just responsible for rendering the content. You're not responsible for fetching anything, right? So let's do that. So let's copy that. So in the user table, in the people table, right, what we're going to do is that we're not going to go fetch anything. So no database, right? We don't have a database, and we're not going to filter anything, right? So instead, we're going to pass you as an argument the users as an array, right? And that property of users as an array is going to be optional. You don't even have to pass me users. If you don't pass me anything, I'll default the users to be an empty array, right? If you pass it to me, great. I'll go in and render them. No filter. Any filtering should happen, outside of me. Someone else is responsible for filtering. Presumably, even the server or database is responsible for filtering and showing you the correct users and whatnot, right? So that's above my pay grade. You just give me the users and I just render them, okay? And now let's create a user screen, right? That is going to render my people table, but here is going to allow us to implement filters, drop downs, buttons to create new users, right? So it'll allow us to do some CRUD operations on the users, right? So let's create a user screen, and this should only be available to system administrators. So there's this user screen, and there it is. So let's look at it real quick. So basically, it's loading our people table that we just edited, right? And what it's doing is that unload, right, is fetching all the users, right, and storing those users in a local state variable, and we're going to pass in those users to the people table that we have here, right? And so now we need to display this user table. Right? So what we're going to do is that we're going to add a new route, right, in the account screen. Right? We're going to add a route over here that's going to allow us to navigate right to the user screen, right, which is going to go fetch the users, right? So we should be able to take a look at that, right? So we should be able to say navigate to users, and there it is, right? We can see that the this information is from the users that we went to fetch. This Robert Marley, see that? And so we're going out to the server, right? And the response is all the users, including Bob, right, and Robert Marley that we just created. Everybody good? Just to make sure that this is indeed the live data that we have in the database, we can go and modify this to confirm. So this is Bob instead. We'll do update. If you go here and we refresh, so this should change from Robert Marley to Bob Marley. So let's refresh. Indeed, there it is, Bob Marley. So this is coming straight from the database. Pretty good? All right. Now, I don't want to have to type here users. I want to be able to navigate from the links, okay? And so what we're going to do is that we're going to add a new link that will only display if the current user, right, is admin, right? So let's see. So in the user, so let's grab the navigation, the account navigation, and we'll add a new link down here, right? That based on the current user, right? If the current user whose role is admin, then I will show that, right? Also, let's create an active function that will allow me to highlight this link, right? Based on the path. If the path matches the path, then we highlight it. Okay. So let's see. We go here. So I haven't even signed in, so I should sign in. So sign in as Bob. Right, 1, 2, 3. So this is testing the URLs endpoints that we had created earlier for signing in and signing up. Right. So let's see. Go sign in. So the user came back, and it is Bob Marley, whose role is admin. So if I go to account, I should be able to see users. Right, there it is. And if I click on users, right, it navigates to the users. Perfect. I think we're missing a border 0 somewhere. So let's fix that real quick. And here the link probably needs to be border 0. And did I miss something? Border. Oh, that's in the class name, active. The link, users, border white maybe? There we go. So I can navigate between users and profile, right, and fetch the users to display them here. Everybody good? All right. Now notice if I log in as someone else, I shouldn't be able to see that this users, right? So let's try it out. If I sign out, I should be able to sign up. Let's try that too, if that's working. So let's join as, say, Adam. Let's say sign up. So that works, right? But notice that Adam is not a admin, right? So Adam doesn't have a link to users, right? Now, obviously, if I know the URL, I can still navigate there, user. So we should protect this this route, right? So that if you try to navigate here and you're not in the correct role, it should kick you back either to your profile or to your sign-in, right? Now we can definitely fix that, right? I can go back to the database, right, and we can confirm that that user was created. There's Adam, right, and I should be able to edit Adam, and I can create a new. I can create new fields, right? For instance, I can change this to or modify existing fields. So instead of user, that's the default role, I can change this to admin, right, and say update. So now if I sign out and then sign back in as Adam, Okay, the role should now be admin and it has access to the users. Pretty good? Okay. Also, I don't have fields such as first name and last name, but we can certainly add them. Okay? You can add them by saying that I want to edit, right? And then you can add new fields here. You can say create a new field after the password, and the field would be first name. This would be Adam. I can create another one here. This would be last name, Sandler, and say update. There we have it, right? So now if I sign out and then I sign back in as Adam, sign in, account, there we go. We have Adam and Sandler. Everybody good? All right. Okay, so let's now learn about doing various operations, right? Various CRUD operations. Right? We know that we can create new users by signing up, retrieving users by logging in, right? And retrieving all the users using find all, right? So let's do other things, right? Let's learn, for instance, in the people table, you'll notice that we have a couple of features that you have a list of all the users, but then you can also filter by their role, right? You can say, give me all the TAs, so it filters all the TAs, or give me all the faculty or teacher, right? And gives me just one teacher, right? And so on and so forth. So I'm going to do something like that. Also, I can filter, by the user's name. So I can say, VIR. So notice it filters as I type, goes out to the server and filters. So let's see if we can implement that, okay? So to implement that, let's first search users by their role. All right, so let's do that. So on the server side, right, in the DAO, we have filter user by role. And the implementation basically is that, just like we used here to filter by their username and password, right? This one is going to retrieve. Notice this one says it uses find one, right? Because I only want one. I know that the username is unique, right? So it's always going to give me one single document, right? But what about if there are several users that match a criteria, right? Like for instance here, I want to match by role, but there might be many users who match by that role. So in that case, we use find. So find always returns an array, even if it's an array of one item, right? Find always return an array of all the documents that match that criteria, right? So this would be our predicate, right? The role that matches. And again, I can, I can just use the abbreviated version of this, right? So once I have that, I can, now go back to the route, right, and change it a little bit. Now, the way the way typically we would filter this is that here, right, you would provide the filter as a query string, right? So all the users will go to just API users like this, right? But to filter, typically, if you're filtering by primary key, the filter would be done as part of the URL, right? So you would provide, say, the ID of this user, right? And that presumably would filter that one user, which we don't have implemented. So that's going to give us a nothing, right? Because there's no, we didn't implement that. But now, if we're filtering instead by something other than the primary key, right? If you are implementing RESTful APIs, the convention is that those filters by non-primary key will be done in the query. So it'll be question mark, the field that you're filtering by, and the value that you're filtering by, right? So by role, you say role, TA, faculty, student, blah, 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 okay? So again, so this hasn't been implemented. Let's implement it. Now, notice that, if I go to this URL with the query string, notice that it's always coming back with all of them. It's not filtering anything. Where's this grabbing this data from? So basically it's going back here, right? It's going back to the find all users, right? That it's implemented, by this URL, this one, find all users, okay? So it's here, right, that we need to be able to filter things, right? If there is a role. we would like to be filtering that. Right? So that's what we're going to do. We're going to, in the find all users, we're going to add, right, to check to see if there is a query, right, at the end of all users, right? So in the find all, right, before we just decide to return all the users, first, let's check to see if there is a role query, right? So if there is a role query, right, if there is, then I'm going to use my DAO implementation of filtering by that role. It gives me those users, and I immediately respond, back to the client with this subset of users, right? And then immediately return. Right? Notice that it's important to return because notice that a little later we have another response here, right? So you can't have two responses. You can't have, I'm going to respond here and then I'm going to respond again. That's a no-no, right? The server can respond only once. Okay, so that's why we are returning right away, right? You can also put it in if else. Right? Okay, so we have that. And so if we go back to our URL here, we should be able to now, filter by role. There it is. So it comes back with Bob and Adam, right? And do we have TA? Yeah, we have a couple of TAs. So it comes back with that. So yeah, so that works. We want to do that from the user interface though, right? So from the user interface, what we'll do is that we're going to create a client function that is going to send this request right out to the server. Is going to encode the role as part of the URL. Right? So in the client here, right, we're going to pass in a role as an argument. We're going to encode that in the URL, and that's what we're going to send out to the server request, to generate a request just like this, right, encoding the role as part of the URL. Okay, so once we have that in the user screen, right, we're going to add a drop down where you can select, right, what role do you want to filter by. So we're going to have a state variable that is holding the filter that we're going to filter by, and then we're going to have a callback here, an event handler that as you choose from the drop down, right, it'll make a request, right, and send the role to be filtered so that it will come back with the users, right, and then we'll set the local users, right. So let's do that. So in the user screen here, what we'll do is that here's the event handler, here's the new state variable, right? And based on that state variable, right, if you select from the drop down, right, that will set that, right, and it will copy that value here, right, and it will either, if there is a role, it will call the find user by role. But if there is no role, right, I'm going to fetch all the users, okay, which we already implemented down here, okay. So yeah, maybe this wants to be implemented a little further down. That okay. So now that we have that, right, we need the drop down. So let's create the drop down where we have options such as all roles, filtered by student, by faculty, by TA, by admin, right? So let's add that like here in the users. And so in the user interface, right now am I logged in Adam? I'm not logged in. So let's log in, Adam. Okay, sign in. And here, users, so there's all roles, right? So if I click on all roles, I can filter by faculty. So we have these two faculty. We have assistants, these are the assistants, the administrators, right, Bob, right, or all the students, or all the roles. See? Okay, that works, perfect, right? All right, how about filtering now by other predicates, right? Not just role, but maybe filtering as I type, maybe filtering by name, by last name, and things like that, right? So what we're gonna do is that in the DAO, right, we're gonna create a new function, filter users by some partial name, right? And to implement that, we're gonna use a regular expression, right? So let's add it down here. We're gonna pass in, what as you type, we're gonna call this function. We're gonna create a regular expression so that we can pattern match a partial match on the field's first name and last name, right? So the predicate is that we're going to create an or Boolean expression, right? That says, okay, well, I want to find right, all documents who match either this predicate or this other predicate. And the predicate is that there's a pattern, there's a partial match on the first name, matching the regular expression that you are typing, or last name matching that regular expression. So either one that matches, is going to bring in that document, right, and is going to create an array of all those documents. That's what's going to be the response. Okay, so from the routes point of view, right, it would also be included as part of a query, right? The name as I type will be part of a query, right? So in the on the server or in the route, right here where we're also filtering by role, we're going to add name, some partial name pattern matching, right? So if we're not filtering by role, perhaps we're filtering by name. So we're going to check to see if there's no role, then we continue, but there might be a name. If there's no name, we continue and we return all the users. But if there is role or name, we're going to either filter by one or the other. So name, if we have a name, it's going to use this DAO we just wrote, right? And return those JSON and immediately return, right? Because again, we don't want to have the second response, right? So now to invoke that from the client, right? Let's create a client function, right? In the client file here that we're going to pass, the partial name string that is going to be encoded in the URL sent out to the server, and the server will return, those are partially matched. Okay. Now for the user interface, right, we're going to create a new input field that as we type, right, it's going to invoke the function to filter the users by this field that I'm typing, right? It's going to save it in a local state variable, right? In the users, going to have a local state variable that, again, I'm typing in the input field, right? And as I type, it'll use a name, it'll send it over to the server, it'll do a pattern match, and it'll come back with the users that match the criteria of pattern matching first name, pattern matching last name, right? And then it'll copy the users into this local state variable and it'll rerun. Now, if you don't have name, right, it'll fetch all the users. Okay. And so this is going to be invoked by a new input field, right? A new input field that we're going to put here, right there. Oops. There we go. So as I type, it'll filter the users by the name, right? And it will re-update the array, right? That will provided by the people table who render it. All right, so let's try it out. So if we go here and say I start typing M. Okay, so just the first character filters only those names that have an M in the name, right? So Romanov, Adam, Bob. Let's say one more letter, M-A. Okay, Romanov or Bob Marley. Right, so notice that the queries are encoded as part of the URL, right? And it comes back with the partial subset of the users, right, that match that criteria. So if I keep going, Marley, so notice it returns only one user. There's that one user that matches. Everybody good? All right. All right, how about being able to retrieve an individual user, right? So yeah, we're going through several CRUD operations, right? We're trying them all out, right? Retrieving all, retrieving partial, retrieving an individual one, right? So we did implement this already, or in our DAO, right, where we are in our DAO, right, that we can retrieve a user by its their primary key, and so we can implement the route. I don't know that we had implemented. Let me make sure. In the route, the find user by ID. Okay, we did not. Right, so let's paste that in. It's going to use the DAO implementation of finding the user by the primary key that we're going to encode as part of the URL. There it is, right? So there's the URL that encodes the ID. We're parsing it out, right, and passing it to the function to that retrieves that individual by its primary key. Let's find one, and then we return that one user. Okay. So once we have that, let's be able to see if we can call it from the user interface in the client. Right, so in the client, we want to call that individual, encode the ID as part of the URL. Again, following RESTful Web API convention, right? That we encode primary keys in the path, but if we want to filter by primary key, but if we want to filter by anything other than the primary key, we encode it as part of the query. Right? All right, so let's try it out. Right, we have that. So what we're going to do is we're going to create a brand new component. Right, we're going to call it a details component that is going to implement this little kind of like this hover dialog, right, or this hover sidebar, right, that's going to sit on the right-hand side floating on top of our table that is going to display, right, users, right, as I click, right, it'll display that particular user, right, in this little sidebar on the right. I mean, we could have chosen a different approach, right? Like in the assignments, the approach that we took was that when we click on an assignment, it navigates to an entirely different screen, right? That fetches that assignment, and so it allows you to edit it. In the modules, we chose a dialog box, right, that pops out the dialog box. You can maybe edit it and then dismiss it. Right here, yet another option. Right, I like to give you different ways of working with partial data in dialogues or sidebars, right, or new screens. So we have this sidebar that what's going to do is going to parse the ID of the user that you clicked on. We're going to convert all these hyperlinks into all these names into hyperlinks, so that when you click on it, it's going to encode the ID of the user in the URL, and we're going to pull out that ID, and we're going to load that specific user, right, and display it on this sidebar, right? So yeah, so let's implement details. We'll put it next to the people table, right, which I believe was under here. This table will create details in there. Perfect. And there it is. So there's the people details screen. So it's going to load the user ID, right, of the unique identifier, right, and then it's going to pull, if you have an ID, if it changes, right, it's going to pull from the users, find the user by their primary key, send it out to the server. The server will come back, and then we can copy that user from the server into our local state variable and then just render it here. Okay. Yeah, so we have that. In our people table, so we want our new sidebar to display on top of the table. So what we're gonna do is that we're gonna literally put it on top of the table. Right. So we're gonna import that. In the people table, we're gonna import it right here. Okay, and then we're just going to render it on top of the table, like over here, that. And we'll create a hyperlink that allows us to navigate there. Let's see, so this is on the people table. So this is the table. So what we're going to do is that we're going to convert the first name and last name to hyperlinks that is going to allow us to navigate to our details screen, right? So there's our link, and this is our link. There we go. Oops. Okay, and we'll need to import the link. There we go. Right, so that's going to navigate there. So notice that if I click on this, notice these are hyperlinks. If I click on it, it doesn't navigate anywhere. It doesn't show anything. Basically, we want to stay in the same screen, not go anywhere else. We just want to show not only the table, but I also want to show the sidebar, right? So to do that, right, we're going to need to add a route. We're going to say, hey, if there's an ID at the end, like we have here, that we have an ID, I still want to show the same table, but in addition, I want to show the sidebar. Okay, so we're going to do that by creating a route, right? That whether you have an ID or not, right, you are still rendering the same screen. Okay. So let's head over to the account here. We're going to add a new route. So if you have an ID, we're still going to be in the users, right? So let's see. There it is. See that? There we go. Right? We clicked on Bart Marley. We click on Bruce Wayne. Notice that it goes out to that particular user. Oops, user, that one. Nope, that one. Right, so if you have the ID, it goes and fetches that particular user, right? Dark Knight, which is Bruce Wayne, right? And then it displays it here in the sidebar. Now, how does the sidebar appear? Let's look at real quick. Sidebar. This is the sidebar. Notice that it uses a lot of Bootstrap classes to position it on the right-hand side fixed, right? And then on top of all the other ones. Well, in this case, on top of the table, right? And then we added this top and end, so that it's stuck on the right-hand side, top so that it's stuck at the top, and then bottom so that it's stretched, right, as a height the entire screen, right? And then white, we added some shadow, right, to make it a little more interesting, right? What else? The table, probably I want to force here a space. There we have a space in here. So we have Tony, Bruce. Now the way I close this sidebar, whether I show it or not, the way I navigate here, let me show you. Right. So notice that if I don't have any user that I haven't clicked on, notice that it displays it displays that user based on the ID. So how is it that we decide to show it or not? Right? How is it that it displays and pops up? So very cleverly, it's very simple. It checks to see if you have an ID from the params. Like over here, there's no ID, it's not shown. But whenever there's an ID, notice that it displays it. Very, very easy. So we're parsing the UID from the params, right? Now, if we have an ID, right, we go and fetch the user by their ID, blah, blah, blah. But notice that if there is no ID, we return null, meaning this component does not render anything unless you have a UID. Right? So if it does show, it'll show on top of the table, right, to the right-hand side, stretched vertically. But if there is no UID, it won't even render. It'll be null. That's how it if there's no ID, notice it's not shown at all, right? The other thing about navigating back and closing, the way I did it was that I'm using a navigate -1. Navigate -1 basically says that the navigation feature in the browser maintains a history of all the URLs that you've been, right? And what navigate -1 does is that it kind of goes back in the history, right? So go back to whatever URL you were, right? So it works the first time around when you click on it, right? The first time around, then you click, you're going back to the URL that didn't have any ID, so that's why it closes. It doesn't work as well if you start clicking around, like Natasha, Thor, Bruce. It's appending all these things to a stack, right? And -1 just does the pop on that stack. So if I click here, it's going to navigate -1 and go back to Thor because it remembers that I was just at Thor, right? It had the ID for Thor. If I go back again, then it'll be the ID of Natasha Romanoff. So you see Natasha Romanoff, right? Eventually, if I click X enough, it'll go back, that there is no ID anymore, and it goes away, right? Okay. So, I mean, it's fine, right? It's a quick implementation of hiding, things like that, and I wanted to show you that, right? How about deleting a document? So deleting a document, right, it'll use the delete user, right, delete one that we implemented in the DAO, right? So we have that already, delete user that removes the document from the database. So we have that already. But how about the route, right? So let's implement the route. I think we do have this app.delete, but we don't have the implementation of actually deleting using the DAO, right? So we go to the route and we look for the delete user. There it is. It's not implemented. I'm just copying and pasting it here. Oops. So copy, and this is delete, paste. There we go. So basically, it's encoding. It's grabbing the ID from the request, right, and sending it over to delete as an await It's going to remove from the database, comes back the status. Now, all the other queries like find user, right, blah, 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 create, all these return an object, the record or records, plural, in the database. Now, delete and update do not. They don't return the object. Well, delete makes no sense because the object doesn't exist anymore, right? So what object am I going to give you? Instead, both of them, delete and update, return a status, right? And that status, right, contains, how many documents were affected, whether it was successful, whether I actually was able to delete or update, right? So status, provides all that meta information, which I'm just going to send back to the client so that the client can do whatever it wants with it, right? I'm going to mostly just ignore it, but I could use it for error messaging, right? So for instance, if I delete something and it comes back saying, no, I wasn't able to delete anything, right? Maybe I can use that, right, in the client, right, to pop up some kind of warning or whatnot, okay? So once we have that on the client side, right, we're going to do the delete, right? On the client, there's our delete. And it's going to just encode the ID as part of the URL. Again, very much like a RESTful web API, right? And then on the client, right, we're going to have created an event handler that's going to actually send out the delete request out to the server, right? And that's going to be invoked by when we click on cancel or delete, the delete button, red delete button, right? So on the detail screen here, right, we're going to have a delete event handler, right, that we're going to invoke when we click on the delete button, or cancel. Cancel will also not delete, but will dismiss this this dialog, right? So let's see. Towards the end, there we go. And then so we go here and we click on, say, Thor. Notice that now we have cancel and delete. Cancel works by just navigating -1. Whereas if I click on delete, right, it should remove it, right, and it'll also force a refresh, right, to fetch and update all the users. So delete, there it is. So Thor's gone, right, Bruce Banner, delete, boom, it's gone, right? Notice if I refresh, they're permanently gone, right, from the database. They don't even exist in the database anymore, right? They're gone, right? All right, so we have a create. Well, no, actually, we didn't do create a user, right? We did delete, right? We are retrieving all the users. We're retrieving an individual user. How about updating a user, right? So update, we did create the in the DAO update, right? Using update 1, right? Now in the route, right? We're gonna implement the update route function, right? Here in the routes. So we have update. So that should be mapped to put. Let's see, put update user. There it is. There it is. So it's implemented, using our old ways. We might, yeah. So wait, we did await current user. Okay, so this one just adds a little bit of a logic to make sure that if I am updating myself, then I also update my session object, right? But if I'm updating anyone else, then I don't have to touch my, my current user, logged in user in my session, right? So this is a little smarter. Let's copy that, and so let's replace this implementation like that. And then now for the user interface, right? We need a service, right, that we can call the route, right, from the client. So so from the client, we have here an update. Oh, I think we already have an update. Let's see. Update, yeah. So I'm not quite sure. I don't think it's very different. Let's paste that. Yeah, same thing, right? We are updating and sending a put, right, to user ID. Perfect. And then what we're gonna do in the user interface, right? What we're gonna do is that we're gonna click on the user. We're gonna go there. So we're gonna implement it so that we're just going to allow you to edit for now just the first name and last name of the user. Although the assignment does ask you to go ahead and just to practice, try to change the role, right, or the section, or any one of the other fields, right? But I'm going to show you how to edit the name of the user. What I'm going to do is that I'm going to add a little pencil here, so that when we click on the pencil, it'll replace the name here, right? It'll replace it by an input field, right? And the input field will be populated with the first and last name, so I can edit the names there. And then when I press on enter, right, it's going to grab those changes, it's going to split it into first name and last name. It's going to send an object to update on the server. The server will update, and then it'll come back, and we'll see the updates here in the user interface, right? So let's do that. Right. So what we're going to do is that we're going to bring in the pencil and check mark and user circle onto the user interface, right? In the details, I believe, right? Yeah, details. So let's bring that here. Yes, we already have the user circle imported. And then we're going to have two input fields, two state variables. One of them is so that we can keep track of the new name, right? So I'm going to be editing this here. And the other is going to be a flag that will know whether we, which mode are we in? Are we in a read-only mode, and we just reading the information, or are we in an edit mode, right? That we are actively editing that field, right? So we need to know and toggle it, right, to know which one we display. And also, we're going to have an event handler called save, right? That is going to, when you click on the save button or the OK button, or maybe press enter, right? It's going to take the string that you've been editing, the first and last name, with one single string. It'll split it. It'll split it so that right in the middle where there's a space, right? So into the first and last name, we will parse it out. We'll destruct it into two constants, the first and last. It'll create a new version of the object, which will be the old version merged in with the new version, overriding the first and last name. And then it'll send this to the database, to a server, and say, hey, this is my updates. Here's my new first and last name, and the database should update it. Okay. Locally, I'm going to copy that value to my local state variable, right, and then just stop editing, right, and then we'll navigate back to the list of all of the users. Okay. So we're gonna add some logic so that if we are not editing, then we want to show just plain old first name and last name. But if we are editing, we would like to show an input field instead. All right. So let's do that. So let's display the user first and last name only if we are not editing. Also, if we're not editing, I want to show a pencil icon so that I can click it and it puts me in the editing mode, right? And whereas the check mark, right? Also say, if I click on the check mark, right, it'll grab those changes, first and last name, right, and send it over to the server. Okay, so let's replace, right, the first and last name here. Let's replace that right there. Oh, let's remove that too. There we go. So we only show the first and last name only if, right, we are not editing. But if we are editing, we don't show that. Okay. So now if we are editing, I don't want to show the text. Instead, I want to show this input field, right? So right after that, let's have, if we are editing, we'll show the input field. All right, let's try it out. All right, so now we have the pencil that we say, so either by clicking on the pencil or by clicking on the name itself, notice it shows the input field instead, where we can type in the value. We can either cancel and the update does not happen, right? Or, right, if I say I go to Tony Stark, right, I can, wait, let's close that, Tony. There we go. We can change from Tony, maybe we can say Antonio, right? And we say either enter, right, or click on the checkbox. So we say enter. Notice that it goes out to the server, right, with the updates. there's the update that goes out to the server, right? The put, which I'm sending the new name for the first name, that's going to merge into the database, and we can confirm the database. So let's see, we still have Tony. I'm going to refresh this, and there it is. Antonio has been modified. Okay, yeah. So that worked as expected. All right. How about creating new elements, right, and inserting new documents into a database, right? So for that, right, I believe we did create the DAO version of this, right? We removed the ID. We used model.create. Yeah, perfect. Now on the route side, let's see if we created that already. Route, we have create. That will be the post create user. Oh, yeah, we had not implemented it, so let's paste that in there. So we're going to, it's asynchronous. It's going to go out to the database, creating a user with some object data that's coming from the client. The client is going to, presumably is going to provide some input field where I can type, first name, last name, date of birth, blah, 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 right? And then that's going to come from the user interface in the body. I'm going to insert into the database, and then I'm going to respond with this new user that has been just created, right, with its own primary key, right, insert into the database, and then what the user interface can do is just update, any state variables on the user interface to give a feedback that this user indeed was just inserted, right? So we have that. So let's also create the create user function in the client so that we can invoke and post the request to create this new user, right? So in the client, do we have create create course? Okay, all right. It looks like we don't have create. Okay, there it is, create, and it's going to post the new user object, right? And then what we're going to do in the users, right? We're going to add a button, right? A plus button, so that we can create new users, right? Now, ideally, we would have maybe a dialog that would fill in all the fields of the new user, right? I'll leave that up to you. What I'm going to do is I'm going to just create a bogus user, right? So just some placeholder for a user. I can always go back and edit it, right, using my details screen, right? So let me create the user, right, and put it in the users here, right? There it is. So there's my create user, and so it's a boilerplate user with some bogus first name, last name, and username, blah blah blah. I can always come back and edit it, right? And we're going to invoke that with a new button, right? A red button with a plus, right, at the top of the screen that is going to allow me to create these new users, right? So here at the top of here, right there, it's going to be a new button that is going to invoke the create user, right? We're going to instantiate it, right? Add it to the local array, right? To illustrate that the new user was created, right? All right, so let's try it out. So here, let's clear that out. So new user, there it is, new user 10, and the server, the request went out, right, with some boilerplate user, first name and last name. I can always edit this, right? I can say, click on this, there it is. I can edit it. I can say Frank Herbert, right, and say enter, right, and that gets updated. I can refresh, and the user is still there. See that? Okay, so the next section walks you through doing all this and replicating this, but server. And then you need to do set up several environment variables. Make sure that you create an account in the MongoDB Atlas cloud service, right? And then we can import all the data that we have here, import it into the remote database server, right? And have all this setup that we have locally on our machine, but remotely, right? And same thing also in the Node.js server. Instead of running locally, right, it's going to be running on Heroku or render.com, connecting to the Mongo Atlas cloud service as opposed to our local database, right? So you have to be able to replicate everything that we have so far, but running in a remote environment, all of that, right? So go through this. it walks you through doing all that, setting up the database, right? Configuring the connection, right? The database connection. One thing to point out, right? To connect to the remote database, right? Running on Mongo Atlas, right? It'll give you a connection string, right? And the connection string has it's very peculiar. Right? It'll include your username and password as part of the URL. Now, just to point out here is that this password that you choose, to log into the database, right? That password should not have the ampersand symbol, right? Because the ampersand symbol is a reserved character in the URL, right? That is used for identifying the name of the machine where this is running remotely, right? So careful, do not use password for that. Okay. Now, this is okay to put this in an environment variable, right? Because, including the password, because environment variables are not inserted into source control, right? It only lives in the local environment, right, outside of the source code. So it's fine. It's safe to put that in there. Also, as a word of caution, right? After the name of the machine, you'll see a slash. See that slash, right? And after that slash, you have the name of the database. Okay, you need the name of the database as part of the URL. Otherwise this won't work, right? And I don't remember. I don't think when Atlas creates the URL for you that you can copy. I don't remember that it adds or includes the name of the database as part of the URL. So you are responsible to confirming that there is a name of the database at the end of this URL. Okay, otherwise it won't work. Right? It's very similar to what we're doing here on the server. In our environment. Notice that we are making sure that at the end of the machine name, there is the name of the database. See that? So same thing, right? When you use the remote version of Mongo Atlas, also you have to make sure that you have the name of the database. Right? Also, there's a query that Mongo Atlas gives you that it is required. You do need that query at the end. Rewrites and app name, blah blah blah. Right. So make sure that you include that. Right. This is the name of the application name when you go through your user interface to create the database. It asks you the name of the application that you're building. You can call it whatever you want, but I chose the name Canvas. Careful that this name of the application is not necessarily the name of the database. They can be different, right? Yeah, that's it. Okay. All right. So we're going to continue this discussion later and next week. I know it's Thanksgiving. I'm going to meet maybe earlier in the week. Right. I'm going to provide a recording. Right. You don't have to come. Right. Or I'll find a recording from earlier semesters. Right. How to do all this. Right. How to apply all these skill sets to refactor a lot of the work that you're doing for Canvas, right? So for instance, courses, modules, right, and enrollments, right, and in particular, right, it's going to discuss how to implement one-to-many relationships, how to implement one-to-many relationships where one course is associated to many modules, right? One course has many modules. First, we're going to learn how to create the one side of a one-to-many. We'll create courses. And then once we have courses, then we can create courses. We can CRUD courses. We're going to learn how to create many modules associated to one course. So that's a one-to-many relationship. And then we'll cover also how to create and work with many-to-many relationships, right? Where, for instance, one student might be enrolled in many courses. Right. So from the point of view of the student, we are associated to many courses. Right. You give me are you a student? I'll give you all the courses that user is enrolled in, and vice versa. If I give you a course, there might be many students, enrolled in that course. Right. So give me a course, and I can give you the students associated in that course. So that's a many to many. right? One student to many courses and one course to many students, right? So again, look up for that recording. I'll make available so that you know how to implement that. Although it's in the assignment, you can go through the assignment and implement that, right? But I will illustrate it, you know, just to show you. All right. So yeah, that's where we're going. All right. Anyway, that's all I had for you today. Let's take a short break, right? And then we'll jump into office hours. Okay. All right. I'll be right back. Don't go anywhere. Well, if you're staying for office hours.